a line has one end 30 mm in front of VP and 15 mm above HP, and the other end is 15 mm in front of VP and is above HP. The length of line is 60 mm and top view of the line is 40 mm long. Draw the two views of the line and obtain the inclination with HP and VP. So as he says, as one end, a line has one end 30 mm in front of VP and 15 mm above HP. So when you look from the front view, we can see the distance above HP, which is 15 mm. When it is projected, that will going to fall on the vertical plane. So that 15 mm above HP we can see in the vertical plane, and we mark this point as P dash. Similarly, when you look from the top view, we can see the distance 30 mm in front of VP. The distance can be seen in the horizontal plane. You can see mark this point as small p, which is here. And so then, and when you look from the top view, we can see the distance other end is 15 mm in front of VP. So in front of VP distance can be seen in the HP. So you will going to get the locus of Q in the top view. So once you know that the length of the line, which is the true length of the line, is 60 mm. So with P as center, taking the radius of 60 mm, 60 mm, cut an arc on the locus of Q. So you are going to get the true length in the horizontal plane. So once you get this true length in the horizontal plane, you know that it is true length in HP. So when it is in space, you will going to get this 15 mm above HP, and this is also 15 mm above HP. So you are going to get this line, which is PQ1. Then the top view line is 40 mm. So with P as center, taking the radius of 40, cut an arc on the locus of Q in the top view. So you're going to get small PQ now. Once you get the small PQ, when it is projected, you will going to get the this capital PQ, which is 40 mm. So how to find out that, we will going to see now. So we know that capital PQ1 is the line which is the true length in the horizontal plane, because it is already given. So with P as center, taking the radius of PQ1, you rotate that such that it will going to fall on this end projector line, because once you have the top view, the front view point of that line Q will going to lie on this vertical end projector. So with P as center, by rotating PQ1 such that this capital Q will going to lie on this vertical line of this end projector line. So once you get this, you will going to get this point. Once you get this line, so you are going to get the locus of Q in the front view. So how to do that? When you are rotating, actually we are considering the front view point. So to get the front view point, I should consider the top view true length. So with P as center, so with PQ1, you take this line which will going to be till here. So that means P dash and Q1 dash will be above HP by 15 mm. So when you are rotating this Q1 such that this will going to be lie on this end projector, so that means the image will going to be rotated in the front view. So with P dash as center, taking the radius of P dash Q1 dash, Q1 dash as the P dash Q1 dash as the radius, you rotate such that that line will going to fall on this top view in projector line, so that you are going to get this point Q dash. Once you get this Q dash, which is on the orthographic, that is in the vertical plane, so you will go to get the locus of Q in the front view. Once you get the locus of Q in the front view, now we need to find out the true length in the vertical plane. So to find out the true length in the vertical plane, with P as center, taking the radius of PQ, you rotate it such that both P and capital Q2 are in front of VP by 30 mm, both. Once you get this line PQ2, so that means when you look from the front view, you are going to get the true length line. So when you are rotating in space, what happens? In the top view, that is in the horizontal plane, with small p as center, taking the radius of small pq, rotate it such that both small p and small q2 is in front of VP by 30 mm. So then you are projecting that line till to cut to the locus of Q in the front view, so that you are going to get this small q2 dash. Then join P dash q2 dash with a line, and also P dash q dash with a line. So this is how you will be able to analyze this problem in 3 dimension. Now we will going to solve by considering this step by step. So to do that, so first we want to find out the front view line. So to find out the front view line, so what we need to do is, so first we will going to take the true length in the top view. Once you take the true length in the top view with P as center, you have PQ1. You know that small PQ1 is the line which is true length in the horizontal plane. So that means both small p and small q1 dash both should be above HP by 15 mm. So that means capital P, capital Q1 should be above HP by 15 mm. So once you get this, so we know that Q1 which is here should lie on the end projector of Q, that is on this line. So with P as center, taking the radius of PQ1, you rotate that capital Q1 such that this will going to lie on the this projector line, so that you are going to get this point small p, capital PQ. So once you get this line, so when you look from the front view, that image will going to be here. So when you are rotating in space like this, or what happens, the image will going to be rotated in the vertical plane like this, such that it will going to fall on this end projector of the top view point small q, such that it will going to cut the front at this point. So then we will going to get the locus of Q. So join P dash Q dash with the line. So that is what we have explained here. With the XY line, you take the top view true length and you project that till here, because both P dash and Q1 dash is above HP by 15 mm. Then we know that you have the top view point of Q. You know that the front view point of Q dash should lie on this end projector. You take the front view point which is P dash Q1 dash, because it is the true length in the horizontal plane, means it should be parallel to XY line in the top view, in the front view. So you project that Q1 till to the locus of P in the front view, which is here. Both P dash and Q1 dash will be above HP by 15 mm. But actually that the end point of the Q1 dash, that is the front view point of Q, should lie on this end projector with P dash as center, taking the radius of P dash Q1 dash. You rotate it, make it such that it will going to cut on the end projector line, and then you are going to get this point as Q dash, join P dash Q dash. You are going to get the locus of Q in the front view. Now we will going to analyze the other, that is to find out the true length in the vertical plane. We know that the line which is in space, which is PQ, then you rotate this line such that you make it parallel to VP. Both P and capital Q2 should be in front of VP by 30 mm. So when you are doing so in space, that means that small PQ, which is the one which is rotated, and make it parallel to VP. That means PQ2 is in front of VP by 30 mm. So now the line is parallel to VP, so I are getting the true length. So when you look from the front view, that line will going to be falls on P dash Q2 dash, which will going to be the true length in the front view. So here also, when you are rotating with P as center, taking the radius of PQ, you rotate it, make it parallel to VP. That means both P and Q2 is in front of VP by 30 mm. So when you are projecting from Q2 to the front view, it will going to cut the locus of Q in the front view. Then mark this point as Q2 dash and join P dash Q2 dash here. So this is how you will be able to analyze the problem in 3 dimension. Now we will going to solve this using this book. So first we will going to draw the XY line and mark XY and VP and HP. So one end of the line is 30 mm in front of VP. So from XY line you measure 30 mm and draw a horizontal line, and then 15 mm above HP. And from XY line you measure 15 mm above XY line and draw a horizontal thin line. Then consider any point and then draw a vertical projector which is going to be a thin line, such that it will going to cut both the lines at this point which is P dash and also at this point which is small p. Then mark this point as P dash and P. And we know that it is the other end of the point is 15 mm in front of VP. So from XY line you measure the 15 mm below XY line and you mark this as the dash dot thin lines. Then you know that the length of the line is 60 mm. That means the length of the line means it is the true length of the line. With P as center, taking the radius of 60 mm using the compass, cut an arc on the locus of Q here, and you mark this point as Q1, and you mark this as locus of Q in the top view. Then join P and Q1 with little bit thicker than XY line. Then again you know that the top view of the line is 40 mm. So by using the compass, you measure the length of 40 mm with P as center, cut an arc again on the locus of Q, so that you will going to get this point and join P and Q with a dark line, and then you will going to you mark this point as capital P and capital Q in with respect to Q1. So then we need to find out the front view point should lie on this horizontal vertical plane projector, because first we need to find out the locus of Q in the front view. So to do that, we have the top view point, which is both P and Q. So from Q you draw a vertical projector to the front view, and now that means the front view point of Q dash should lie on this end projector line. To get the end front view point, first you take the top view true length. So you know that PQ1 is the line which is the top view true length. So that line has to be parallel to HP in the front view. So parallel to HP can be seen in the vertical plane. So that means it is in the front view. That means P dash is above HP by 15 mm and Q1 dash should also be above HP by 15 mm. So from Q1 you draw a vertical projector such that it will go to cut the locus of P in the front view is here. So and you mark this point as Q1 dash. But we know that the front view point of that Q1 dash should lie on the end projector line of the small q. So you draw a vertical projector from Q to the front view with P dash as center by taking the radius of P dash Q1 dash by using the compass. You rotate such that it will going to cut the locus of to cut the end projector line drawn from the top view point of Q. So and you mark this point as Q dash. Then draw a horizontal dash dot thin projector line, and you mark P dash Q dash with a dark line. Now to find out the true length in the vertical plane, so to find out the true length in the vertical plane, you make that line parallel to VP. So with P as center, taking the radius of PQ, you draw an arc such that both P and Q2 should be in front of VP by 30 mm. So once that line which is P and Q2, which is the top view line, is made parallel to VP, that means it is parallel to XY line in the top view. Obviously, its corresponding front view will be going to be in true length. So from Q2, you draw a vertical projector such that it will going to cut the locus of Q in the front view here, and you mark this point as Q2 dash. And since this PQ1 is the line which is since PQ2 is the line which is parallel to XY line in the top view, so obviously that P dash Q2 dash is the line which is the true length in the vertical plane, and you mark this as capital P in bracket and capital Q in bracket. Similarly, we know that P dash Q1 dash is the line which is parallel to HP. So this is PQ1 will be the line which will going to be the true length, and you mark this point as capital P and capital Q in bracket. Now to find out the inclinations, and you mark the true inclination with respect to HP as theta and with respect to VP as phi, and apparent inclination with respect to HP as alpha and with respect to VP as beta. Then by using the protractor, you measure an angle of theta, which is the true inclination with respect to HP, which will be 48 degrees when you are doing it in manual. When you are doing it in computer, it will be 48.19 degree. And similarly, the apparent inclination with respect to HP, which will going to be alpha, which is 50 degrees when you are doing it in manual. When you are doing it in computer, it will be 50.34. And with P as center, by using the protractor, you measure an angle apparent inclination with respect to VP, which is beta, which will be 22 degree when you are doing it in manual. When you are doing it in computer, it will be 22.02 degrees. And similarly, with respect to VP, true inclination, which is phi, which will be 14.48 degree when you are doing it in CAD. When you are doing it in manual, it will be 14 degrees. So this is how you will be able to write the solution in the